So far, the strategy patterns that we've been looking at have been pretty simple. We basically call a method and then something happens. But the strategy pattern is often used for situations where we need to calculate some value in a different way that we can only choose at runtime. For example, suppose we need to calculate the correct amount of sales tax for items that we sell in our vet clinic. Now, our vet clinic happens to be based in Ireland, and Ireland has a number of sales tax rates that we can see here. We have the zero rate for things like medicine and printed books. So if we have some pet books in our clinic, we could sell them, but they'd be rated at 0. We could have also the 9% rate, the low rate. If we sell a packet of crisps, that would be rated at 9%. And for most things, for pet food, for animal toys, we have the standard rate of 23%. Now let's see how we could do this in code. We want to have a sales tax service. This is going to be an object whose job it is to take a line item from our sales system, which will have a unit cost, a quantity, a description, and a category, and return to us a sales tax item with a tax rate, a tax name, and the amount of sales tax to charge. For example, if we sell a pet toy for our dog, it costs €5 and it's categorized as a toy, it would be charged at the standard rate of 23%. So we would charge a total of €1.15. But if we were to sell a packet of crisps for €1.50, this would be categorized as food, so it would be charged at the reduced rate of 9% with an amount of 14 cents. Now let's see how we do this in code. To save us all some time, I've already prepared some code which can act as a starting point for this exercise. You can find it under the kata/strategy pattern/step 4 start tag in the sample code. As always, we start with a test. In this test, we are illustrating the sales tax we expect to be charged on a €3 packet of crisps. I've already created a line item class and a sales tax class. The line item class corresponds to the line item that we saw in the previous slide. So the line item as it will appear on the invoice and that we receive from our sales software. The sales tax corresponds to the sales tax calculated on this sale. And the sales tax is what we are expecting to receive. So in this test, what we can read this as: for a line item for a sale of 1 salt and vinegar crisps, which is in the snack category and has a unit price of €3, when we calculate the sales tax, so sales tax service, which is at the moment an empty class, sales tax entry for crisps, then the expected sales tax should be a reduced rate of 9% and it should calculate to an amount of 27 cents. If we run this test, then we would expect it to fail, and indeed we can see it fails. So we're expecting a reduced rate of 27 cents, a reduced rate of 9%, but we got null. And we got null simply because this method is empty. Let's see how we would implement this method using the strategy pattern. The tax rate is determined by the product category, which we've represented as an enum. We have a product category for medicine, for books, for snacks, and so forth. In this method, we could put a switch or a conditional statement, but this could become complicated if we have many different tax codes. Instead, we want to isolate the logic of how we determine the right tax rate from the actual calculation of the amount of tax we need to pay. Now, to be fair, if the only difference between the different sales tax is the actual rate itself, then we don't need a strategy pattern. We could simply have a map which would go from product code to the tax rate. So If we had snacks, we would map directly to the reduced rate. If we had medicine, we'd map directly to the 0 rate, and so forth. In that case, we don't need the strategy pattern, and using the strategy pattern would be overkill. We'd rather keep the code simple and reduce duplication. However, imagine that the calculation is a little more complex. And for example, the reduce rate is not just 9%, but under certain circumstances, if the total value of the sale exceeds 100 euros, then we don't apply 9%, we apply 13.5%. If we have rules like this and the actual calculation varies from one rate to another, and we'd need to separate the actual calculation logic for each tax rate. In this case, the strategy pattern would make perfect sense. Let's start by returning a hard-coded version of the result so that we can get a feel for the API. If we remember our test, we want this value to return an expected rate of sales tax at rate of 9% with amount reduced for a total value of 27. If we were to basically copy this, and so all I've done here is actually I'm returning a hard-coded value. Now let's go back to the test. We'll run the test, and this works with a hard-coded value. So our API is correct, and we understand how to use this sales tax API now. However, obviously this is not an optimal solution. We need to find a way to make it work in a more general case. Let's create an object called tax rate, which will represent the name and the value of the reduction. Then from that we can calculate the amount. So we could do something like this. We've got a tax rate, it's a class we'll have to invent. Applicable tax rate. Now we're going to get that from somewhere, so we're going to say tax rate for the item. We're going to need a method to actually return that tax rate from somewhere, but let's not worry about that just yet. Let's figure out what we want our tax rate to do. What we'd like is to replace this rate of by a value in the tax rate, and we'd like the name of the tax rate to appear here, and in that case we can use the line item total value, which returns the total cost, which is the quantity multiplied by the unit cost, and multiply it by the applicable rate. Now clearly this doesn't compile, so we're going to need to create a tax rate, and we're going to need to create a tax rate method. So we'll just have that return null for now so it compiles, and let's add a rate and a name to our tax rate. Our rate is going to be a double, and our name is going to be a string. And I'm going to add some getters there so that we can retrieve the values. So now we have a little simple class, a read-only class that has a rate and a name and allows us to retrieve those values. Now let's implement the tax rate for method properly. At the moment, obviously, it's just returning null, and we need it to return an actual tax rate. This is where the strategy pattern comes into play. We need a different way of determining the rate depending on the item category and the total cost. And for this, we're going to define an interface tax rate calculator that will determine the tax rate based on the item category. We could do this by writing something like along these lines. Tax rate calculator. So this is our tax rate calculator. For the moment, let's create a simple implementation of this interface called reduced rate calculator, which is going to return uniquely the reduced rate that we're interested in. We're going to start from being very specific and making it more general later on. This is a common technique used in test-driven development. So I'm going to create a reduced rate calculator, and that's the code I would like to have. And then here, how do I want this to work? I want my tax rate calculator to return the rate for the item. Here we have the API we want to write. Now let's go about implementing it. I'm going to first create an interface called tax rate calculator. Then I'll go back here. I'm going to add a method on that tax rate calculator. And finally, I'm going to implement the reduced rate calculator. And add the rate for method on that calculator. And now, just to confirm, we have something that compiles. Now all we need to do is implement the reduced rate calculator. And to implement the reduced rate calculator, if we remember, the reduced tax rate is 9%. So we can return a new tax rate of 9%, and it's called reduced. Let's go back to our test and run it and see if it does what we expect. And we can see it passes. Our next step is to make this algorithm more general so that it applies for different tax rates and different quantities. Let's start off by writing another test that demonstrates that the reduced rate is not sufficient, that we also need to cater for larger volumes. And to do this, I've written another test. This test demonstrates that if we make a purchase of over €100, then we will be charged at the superior rate of 13.5%. First of all, I'm going to line up a line item which contains a purchase of 50 salt and vinegar crisps. So 50 packets of crisps at €3 each comes to €150, well over the 100 limit. So this means that we should be charging 13.5%. And if I run this test, we can see that it is not doing so. It is only charging the 9% because our strategy pattern is still fairly basic. So let's see if we can make this work. If we go back into our sales tax calculator, we can see the sales tax at rate of applicable tax rate with the name for an amount of, and we calculate the total rate. All of this code is generic. All of this code will work no matter what rate is returned. The strategy pattern comes into play in this second part where we return a calculator which makes the correct calculation. In this particular case, it's our calculator which is insufficient. We need to expand the logic here so that the tax rate will cater for amounts that are over €100. All we need to do here is return a tax rate of 13.5% if the total sales value is greater than €100. Let's check that. If item get total is greater than €100, then we simply return 13.5 instead of 9. Otherwise, we return 9. Now let's go back to our test and see if this works. Now we can see now we've correctly implemented our reduced tax rate. And we've made the reduced rate calculator work by hiding away the logic inside. Inside the rate for method, we check whether the total is greater than €100 and we return either the 13.5 or the 9% rate accordingly. So this works perfectly for reduced rates. But we still need to do the other two rates, zero rate and standard rate. In the next video, we'll expand our application to cater for these other scenarios.